Now let us see proving that root 3 is irrational. Prove that root 3 is irrational. So again we will assume to the contrary that root 3 is rational. That means there will be two integers a and b such that we can write root 3 is equal to a upon b where b is not equal to 0. And suppose a and b are not in the reduced form, they have a common factor other than 1, so that we can divide by that common factor and then assume that a and b are co-prime. So when you cross multiply, you get a is equal to b root 3. Again square both the sides, you get 3b square is equal to a square. Now this means that b square is a multiple of 3 because 3b square, LHS is a multiple of 3. So if LHS is multiple of 3 and LHS and RHS are equal, so a square is also a multiple of 3. That means a square is divisible by 3. If a square is divisible by 3, it means that a is also divisible by 3. So we can write that since a is divisible by 3, that means a is a multiple of 3. So let a be equal to 3 into some integer c. Now we will substitute back over there value of a as 3c. So 3b square will be equal to 3c whole square, that is 9c square. Now after dividing we get b square is equal to 3c square. Now this means that the RHS 3c square is a multiple of 3, that means that it is divisible by 3, and b square is equal to that, it means that b square is also divisible by 3. That means अभी ऊपर हमने क्या बोला, a is divisible by 3. Now we are saying that b is also divisible by 3. Means a and b both are having a common factor, that is 3. But यहाँ पे हमने क्या assume किया that a and b are co-prime, so they don't have any common factor. But यहाँ पे आ गया कि they are having a common factor 3. That means we have reached a contradiction. That means that our assumption is wrong, and therefore what we had assumed that root 3 is rational, it is wrong, and therefore root 3 is irrational. Okay, so this is the indirect method of proof. Do this also, write it from the textbook.